Hi guys, my name is Parakpal and welcome back in new video of estimation and costing. So guys, this particular video help you to take the quantity and with the help of that, with the help of the rate analysis, you can estimate the total cost of building in which how much labor is required, how much material is required that you can easily identify. So this video is very important for all civil engineers who work at site, who work in consultancy, who wants to start their own work, and the civil engineer freshers. Okay, or you can take this particular data for your project also, final year projects. Okay, so guys, before starting this video, please do subscribe my channel because this video is really very helpful for all civil engineers. Okay, so what I'm going to provide you an information today is we are going to discuss about how to take the quantity with respect to the center to center distance. Okay, because in our engineering we learn to take center to center distances, but that is one of the wrong process. Why so? Let me clear your doubt first. You can see we require this floor plan. If you can see over here, if I take the center to center distance, what does it means? It means this wall also come till this point. But here already column is established. The column is there. Is it really required to take center to center distance? No, not at all. But this particular concept work when there is a junction of wall. When there is a junction of wall is available at that point, you can use this particular concept. But till the point, if you have the column, okay, this concept is not going to work at all. That's why we have software like Revit. So in Revit, you can very easily do this work. Okay, in Revit, in very easily you can do this quantity work. Okay, so we require this particular software for this overall work. Okay. Also, when you prepare a model, Revit help you to provide an elevation also and sections. So these elevation and sections help you to identify the vertical distances. Like if I want to see at what certain distance this window is placed from the bottom. So that's what I want. Okay. So this particular software help you to get that information. Now guys, for this overall exercise, this is one kind of exercise for all of us. So for this, you require this floor plan, which I'll provide you for a downloading. Okay, link is given in the description box. After that, you require this kind of Excel sheet, okay, which you need to prepare. Okay, this you can use on online. Okay, after that, you require my website. Here I have created one course of estimation and costing of building. This course was prepared by 2-3 months back where I provide the students that how to learn the estimation and costing, what are the concept, how to do manual calculations, and how to use this particular sheet with respect to the submission drawing and measurement drawing. Okay, so for that it costs 499 rupees. If you want to do this course, you can pay me 499 by this number on Google Pay, or you can scan this particular QR code to pay me through Paytm or QR code also. Okay, but guys, for this particular exercise, we require these tools. These are the tools. If I on this tool, you can see if I click on rate analysis of tiles, so you can see there is one tool is open called as a rate analysis. Okay, so this rate analysis you need to provide the mixes over here. If I provide different mix, so you will get the total quantity here. Okay, and this quantity you can use for your different work. Okay, so we will get back to this very soon, right? So first of all, what we have to do, we need to go to our Revit model and identify, okay, what is the distances, okay, of the wall, the horizontal distance, okay, and the vertical distance. This particular distance is very important, and make sure you will consider overall distance because we are going to deduct the wall soon. Okay, so now what we have to do, just first click to the annotate and then click on a align. Okay, make sure when you click on align, so here they are asking about wall center line, center of core, faces of core, wall faces. Okay, there are maximum different things. If I click on wall center line, so it will take distances from centers to center, or if you select from here to here, that also work. Okay, so no issue with that. Okay, so just click on wall center line and just start taking the distances of the wall. So I have started the work, so let's do the work. Okay, so just click here, click this point and click this point, and let's take distance over here. Okay, like this work you need to do. Okay, click here and click here, take distance, right? After that, what I'm doing, I'm excluding this column because I know if I take the distance center line till column, that is not for any sort of use. I'm not going to construct any sort of wall construction over here, right? That's why I'm not considering this particular area. Okay, now I'm going to select this from this portion, okay, to this portion, okay, one of these distances, okay, then from this point, okay, to this point, right? After that, similarly, from this point to this point, then from this point to this point, okay. So this distance also we gather. Now we required this particular distance, okay. Now you can see that there is no column at all. Okay, here we not provide any sort of column. Okay, so what we have to do, we need to take distance till this point. Okay, but it will capture the distance till center line. Why? Because we selected the center line distance here. So don't worry about it, we will add plus 150 distance over here. Okay, so after that just come here, do the same work. Okay, from this point, okay, till the end it will not go on, it will come to the center line only. So don't worry about it, we will add the center to center distance. Okay, we have one column here, but I don't know why the column is not here. So there is a column. Okay, we'll consider column over there. Okay, I forgot to add column over there. Okay, so now again we need to do some work. Okay, from this area to this point. Okay, now from this point, okay, to this point. Okay, after that, okay, from this point to this point, then from this point to this point, right? Yeah, like this, then this point to this point. Might be you are getting bored because I am doing the dimension calculations, and this is really one of the important process, guys. Okay, if you skip this process, it means you are not in position to understand how to do the proper work, because most of the people are aware about it that only we need to do the calculations. Okay, but it is not that easy. Okay, now after that we need to do the calculation in vertical manner. Okay, so just select this one. Okay, we will be selecting this particular area, okay, till this particular area, like this. First one, okay. Second one is just follow this line, blue line, this one, okay, to this particular area, okay, like this, right? After that, I'll be selecting. Now you can see this line should be parallel with this. So I am not no need to take the again dimension of this line. Similarly, this line is parallel with this one. So I'm not going to take the distance. Similarly, this line is not, this line will be parallel to this one, like 1, 2, 3, 4, 5, 6. So I not, so it is not essential to take a dimension of all these lines because I know all these are the same. Okay, that's why I'm not going to take a distance. Yes, I'm going to take a distance of this line and this line because there is a similarity here, here also, and here also. Okay, so let's take one distance here. Okay, so I'm avoiding the conjunction of maximum dimensions. Okay, after that you can see we have some toilets works also, so that work is also essential. So take the distances from wall faces. Let's take of the wall faces. Okay, like this till here. Okay, Now from this point to this point, right? So similarly, the distance dimension for this is also same over here. Okay, so now we almost have maximum dimensions, but now we need to take the dimension of the columns also. Okay, so how we can take the column dimensions? Take column dimensions from here to here. It is 300, and from this to this, it costs 450, right? So maximum dimensions are the same. Okay, that's why I'm not going to change it, right? So we have this particular dimension of the column. Now let's go to the dimensions of the uh, beam. Okay, so the dimension of beam, okay, just go to the ang aligned from this portion, okay, to this portion is 400 depth. Okay, height of the column is also one of the important portion. For that, what we have to do? Just go to the this point and come till this point. It is 3000. That means 3 meter. Okay, then thickness of slab, okay, we provided as a base slab, okay, which is 362. Why it is 362? Because it's the base slab we provided, okay, but I'm considering it as I'm going to reduce this one. Okay, we will be reducing this one, so we'll consider it as a 150 mm. Okay, we will reduce this particular slab. Okay, now rest dimension of the window and all we will do afterward. So first of all, we need to do the calculation of the center line. Okay, so how to do this work? First of all, just do the calculation of all x direction scenario. Okay, so for that, I'll be doing the work. Okay, just open the calculator, make sure over here. Now 3090, this particular parameter, plus here 3695, okay, plus 3709, okay, plus 3090. Okay, this become 13,584. Okay, now add this bottom one, 3200 plus. Okay, but we need to add this one with our history. Okay, so our history is 13,584. Okay, so we need to write this one. Okay, let me write all these calculations because I am also I don't have that much of sharp memory to understand all these things. Okay, 584 plus. Now let's do this calculation. Okay, 3200 plus 3709 plus 3709 plus 3200. It means it having, okay, it is 13818. Okay, now just do the calculation of this area. Okay, it is how much? 333350 plus 3500. Okay, so yes, here there are some confusion what we have. So you can see 3350, it means same distance, it will be same. But here we take distance from this face to the center line, and here the distance taken from the center to center. It means what we have to do, just this take this distance 3500. Okay, so it will be like this, 3500 plus half thickness from here this side and half thickness from this side. Okay, it means 3500 from center to center distance. So thickness of wall is 300 mm. It means remaining half distance is 150 mm and remaining this one is 150 mm. It means 3500 plus 150 plus 150. It means it is 3800 and multiply by 2 because we have another same dimension here also. Okay, so the overall distance is 7600. Okay, now after that, come at the bottom. Okay, you need to consider this distance also. Okay, now here you need to consider this particular wall is having very minimum thickness 150 mm only, but we are considering because there is a wastage also incurred for during the construction work. That's why we are considering it our in overall length. So in x direction, our next distance is this particular one. So it is 1300 plus 1300. It means these two distances, right? So let's do the calculation. 1300 plus 1300. It means it is plus 2600. Now let's go come to the bottom directions. Okay, bottom calculation. So guys, this is one of the easiest way what I'm teaching you. Okay, so now just click 3200 plus 4004 plus 2900 plus this particular distance is center to center. We exclude this particular area, so we need to take 4004. Okay, plus 3200. So it means it is 17,308. So this is what one of the x direction distance we got. Now we are going to calculate the y direction distances. Okay, so how we can do the calculation? So first of all, we will do the calculation of this vertical bottom line. This particular distance from here to here is parallel with this one also, this line also, this line also, this and this line also. So how many line we have? 1, 2, 3, 4, 5, 6. So this multiply by 6, it's become all the diameter, all the length of this line. So it is equals to 6630 into 6. Sorry, 6630 into 6. It means 39,780. So 39,780. This is what overall distance we got. Now also there are some vertical distances. This one 2000. So 2000 into 2. It means we have plus 4000. Okay, right. Now after that, just come here. This line is equals to this line and this line parallel to these two lines. It means 6130 into 4, right? So 6130 into 4, it means 24,520. Now this particular line is equals to 1, 2, 3, 4. So 4725 into 4. It means 18,900, right? And don't forget this particular distance, but we consider these distances in our calculation. So we need to do the overall length calculation now. Let's save the model first. Okay, this is very essential, guys. Okay, so that's why I told you it is very interesting lecture. So just do the all calculations. So my calculation step by step, if you can see my history, there is all values are gathered. So what we are going to do is adding of all the values. So 13,584 plus 13,818 plus 77600 plus 262600 plus 17,308. This is what the x direction distance, which is 54 meter 910. 54.910 meter, right? Now do the calculation of the y distance. It is 39,780 plus 4,000 plus 24,520 plus 18,900. Okay, it means 87 meter, 87.20 meter. So we need to add these two distances, which is 54.910 plus 87.2. It means overall length is 142.11, which is the length of a wall. You understand my point, guys? Okay, this is what a total distance of the wall. But now you may be thinking about it, why I escape the value of this particular columns? Because this is also one of the parameter which we are going to encode for a beam calculation also. So yes, guys, I know about it. Okay, that's why we need to calculate how much number of column over here. Okay, because we are going to consider their length. Okay, and only one direction length we will consider. You can consider 300 mm or you can consider the 450 mm. So I am going to consider 450 mm because it consider come in the length directions. Okay, so just calculate the number of columns. So here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, one column here, 21, 22, 23, 24, 25, 26 column we have. So 26, okay, 26 into 450. It means 11.700 meter. Okay, so that is one of the very important one. So 450, it means we have 26 columns. Okay, just multiply by in metric value 0.4. Okay, just let me see what is dimension. 45, right? So 0.45 is a dimension. It means 11.7 is a metric distance for all the columns. So we need to add this particular distance. We need to use this particular distance when we do the calculation of the beam. Okay, only that time we need to do this work. So guys, till the time we learn how to do the calculation of the dimensions. Okay, now let's come to the Excel sheet. Here you need to type the total length, which is 142.11, excluding the dimension of what? Excluding the dimension of the beam. And you need to type the total length including beam is equals to 142.11 plus 11.7. It is 153.81. Now this is very easy. Don't worry about it. You can prepare this sheet at your own, or you can use this Excel sheet, okay, on my website. I will provide you link in description box soon. Okay. So now we are going to identify how much amount of excavation work is required. And this is one of the first step for each and every kind of quantity estimation. So after providing all dimensions, what we have to do, we need to just go over here, click on this sheet. Okay. Now guys, you can see here we need to put the proper dimensions. Like first we need to identify how much overall length. Here whatever length you are going to put, that length should be equals to the work of wall with beam. So you need to take this particular distance over here, which is equals to 153.81. Why? Because we are going to excavate the area. That excavation itself consists the area of beam and column and everything. Okay. So we need to think about it all the surface area. Okay. That's why we consider the total length 153. Now, what is width? How we can identify width? Just go to your Revit plan and go to the footing layer. You can see we have the footing like this. Okay, so just take dimensions. Okay, and check the dimension from this point to this point, and from this point to this point. So it is 1200 and 1200. It means 1.2 meter. Okay, but we know that when we excavate the area, our labor go down and he start his own work. For that, we require some extra space. That's why we considering it as a 1.5. And what is the depth? How much depth we have? Just go to our plan in section or elevation. You can just go to the elevation. Okay, you can see guys from this particular area. Okay, from this foundation area, at the bottom we are going to excavate. Okay, at bottom we are going to excavate. So we are going to excavate minimum 2.5 meter depth because this is a multi-story building model. Okay, so just consider here 2.5. So you can see we need to excavate 576 metric cube work. Okay, now how to do the rate analysis for this? Because when this particular quantity we got, now I want to calculate what is the rate, how much cost will incur for this particular work, excavation work. So in abstract sheet, you can see 576 come over here. Okay, so we need to add rate over here. So how we can do the rate work? So you need to go to my website and click here rate analysis for excavation. Here it is. So just click on this so you can see the another window will open. Now with the help of this window you can see there is a different kind of the work of the for excavation is available. This for the earthwork for site cleaning, this for blasting rock, this for excavation of ordinary soil, this is for the hard soil, this is for the excavation work, okay, this is for the filling of foundation, and this is for the another kind of the work. So now first of all we need to excavate. So just consider this area. Okay, so we can see what we are going to do is we are going to consider machineries also. We have some electricities also. Okay, so just select this ordinary, not ordinary soil, just consider this one. Okay, hard soil. So let's consider it is a hard soil. So we need to put the rate over here first of all. So rate of this particular helper per day is I'm considering as a 300 rupees. Okay, and it require zero point 0.7. So my cost will be 210 rupees. Okay. Now this is what a fixed rates, fixed machineries, fixed rate for the all contingencies work. Okay. So you need to write, you need to put the rate over here. Okay. And you will get the cost. Okay, so this is what very interesting particular calculations. Okay, so I'm considering that for one metric cube quantity, okay, I'll be requiring, okay, this particular cost 276 rupees. Okay, for the like for using the machineries and all and each and everything, I'll be requiring this cost. So what I'm going to do is I'll go here, okay, and put the cost of the 276 rupees. Okay, and you can see equals to this multiply by, okay, so you can see the cost come here. 1.59 lakh rupees is required for the overall work. Okay, and this cost is come from here. I just take 237. I need to take 237, sorry, 237. Okay, 1 point this much cost we required. Okay, 1.36 lakh rupees. Okay, this particular cost we are going to require for this work. Okay, now after that, we require footing quantity. How much of the footing quantity we have? Now this footing quantity work we will start from the next video. Okay, and next video we will do all this calculation work and you will get to know how to do this work very easy quickly. Okay, so thank you guys watching for this video. I hope you like this video and thank you so much. Watch video till end. Have a nice day. Bye bye.